Woohoo, we're live. And this is Math 60, Intermediate Algebra, and we are working on parabolas. And I have to warn you, this parabola is wicked hard. This is not going to be easy. Those of you who are faint of heart may want to fast forward to the last one. The last one's kind of surprising, but not as hard as this one. This one is the hard one, and I thought about it and I thought, well, would it be better to show you an easy one, which you could probably get on your own, or should I show you what it looks like to do a really brutal one? And I thought, let's do the brutal one so you can see. So this is not going to be pretty, but hopefully we will get a um, a graph. And of course, if you want spoilers, go ahead and fire up Desmos and DESMOS. It's the app and the web app and the regular app that will graph this for you. So let's get into it. First thing, I look at this and I see a parabola. How do I see a parabola? I see a parabola right there, the x squared. This is y equals negative 3x squared minus 12x minus 2. This is a parabola, and this parabola opens downward. Why does it open downward? This negative 3 right here. The negative 3 means that it's concave down. So that's the first step, is just knowing what the heck we're graphing. So y equals all of this mess. Next thing, let's Marie Kondo this. I'm going to take the 3x squared minus 12x, and then I'm going to move the negative 2 over here because it is not sparking joy. And you might be worried that we're going to have to do something with that negative 3, and you are absolutely correct. We are going to have to factor that out. I'm going to factor it out of both of these because these are the two terms with x's in them. The negative 2, we're just going to leave over on the side. Don't think about it. I mean, eventually think about it. So I get x squared. Notice that I get plus 4x because there's a minus 12x there. And what I would like to do is I would like to bring somebody in here that will complete the square. Now, hopefully you're already thinking, oh, well, the perfect square would be x squared plus 4x plus 4, right? With the minus 2, and I would say y. So if we have x squared plus 4x, you take the 4, you take half of the 4, and you get 2, and then you square the 2. Right? Now, the problem is when I put the 4 in here, it is also being governed by this negative 3. So I haven't just added 4, I've added a negative 12. So I have to add 12, which is one of the weirder things about this, is that there's so many moving parts. It's like, yeah, when I said this was going to be gruesome, this is going to be gruesome. So again, I didn't just add 4, I added a negative 12. Let me get my blue pen. I added a negative 12. That's why I had to add a 12. Compensate for negative 3 times 4 equals negative 12. Okay. So where are we going to go next? That's a good question. You know what? I'm not going to try to smash it all close like I normally do. I'm going to come down here. I've got y equals negative 3 times x squared plus 4x plus 4. And on the outside, I have plus 10. This becomes y equals negative 3 times the quantity x plus 2 squared plus 10. My vertex is at negative 2 comma 10. Now, is there another way to find the vertex? Do I have to go through all of this? Well, this is standard form right here. So this was part of the problem, to find standard form. However, if you don't need to find the standard form, or other people call it the vertex form, is there another formula? Could we have gotten to this by something else? And the answer is yes. I'm going to take a little bit of space right here. Alternate way to get vertex. The vertex, the x coordinate, is the opposite of b over 2a, which you will recognize as being the first part of the quadratic formula. So in our case, when I come up here, I've got negative 12 is b, so opposite of b is positive 12, or the opposite of negative 12. And 2 times a is 2 times negative 3, so I get a positive 12 over a negative 6, so that's negative 2. Sorry, you guys can't see that last piece. There we go. 12 over negative 6 is negative 2, which matches this. Notice I did this in one line instead of in 438 lines. So if you do not need to come up with standard form, this is the quick and dirty way to get the vertex. Now, that's just the x coordinate. To get the y coordinate, of course, you would have to plug in negative 2 to the original equation. I get negative 3 times 4 plus 24 minus 2. So I get negative 12 plus 24 minus 2 equals 10. Sorry, I shouldn't have drawn the box before I was done. Ugh, rookie mistake. So I could have gotten the vertex this way, or I can do the completing the square process and get the vertex there. So that gets us started, and then we're going to need to find the intercepts. So let's find the intercepts. So if I have y equals negative 3x squared minus 12x minus 2, then the easiest intercept is when x equals 0. So that's y equals negative 2. So we've got the point 0, negative 2. When y equals 0, that's a little bit harder. That's going to be the quadratic formula. Or if you're able to factor this, if it factored, then you can factor it. I'm going to go ahead. I'm going to assume that a lot of people are just going to default to the quadratic formula because it's just the same thing every time. So that would look like this. The opposite of b plus or minus radical b squared minus 4ac all over 2a, because I've got a quadratic equal to 0. So x is, let's see, the opposite of negative 12 plus or minus negative 12, the quantity squared, minus 4 times negative 3 times negative 2, all over 2 times negative 3. So that's going to be 12 plus or minus 144 minus minus minus. So this is a full minus. 4 times 3 is 12 times 2 is 24. Notice this is the part that gave us the vertex in our quick and dirty vertex if you wanted to use that. Right? This part, the opposite of b over 2a, is actually just part of the quadratic formula. It's this first part. Okay. So 12 plus or minus radical 120 all over negative 6. I've got bad news, guys. We're going to have to simplify this. Square root of 120. Let's see, it's 4 times 30. So that's 2 times 2. 2 times 2 times 30. The 2's go running. Oops, sorry, too far over to the side. The 2's go running. Where's my bear? The 2's go running. Ah, the bear comes through. Yum, 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 yum. The 2 comes out, and I've got radical 30. So I've got 12 plus or minus 2 radical 30 all over negative 6. And clearly, I'm going to need another piece of paper. So let me get myself another piece of paper. So I've got I'm dealing with the intercepts, 2 continued. And when y equals 0, x equals 12 plus or minus 2, radical 30 all over negative 6. So let's talk about what to do with that. So what I'm going to do here is I see I have a 2 that I can factor out. And then I can reduce. Where's my red pen? Here's my red pen of destiny. The 2 cancels with the negative 6, and I get negative 3. So I've got 6 plus or minus radical 30 all over negative 3. Okay, so now that minus, I don't want to leave the minus down there. So I'm going to pull the minus out in front. And then I'm going to show you something kind of cool. I think it's kind of cool. As long as we're doing this hideous problem, there might as well be some brilliance in it, right? I'm going to move the minus up. If I move the minus up, the 6 gets a minus, but then I also have to put the minus there. But this is plus or minus. So, and this is not universal, but a lot of people do this. We flip the order to remind ourselves the plus became a minus and the minus became a plus. It's kind of cool. It's not everyone does this. Some people think it's like, oh, don't do that. That's so dorky. So it just depends. I think it's cool. I think it's beautiful. I think we need to come up with some calculator approximations here. Negative 6 minus radical 30 all over 3, and negative 6 plus radical 30 all over 3. So let's figure out what this is on the calculator. Okay, there we go. Ooh, look at me. I was dividing by negative 6. I wonder what that was all about. Okay, so I've got negative 6 minus radical 30 equals, that's the numerator, and then I divide by 3. And this one is negative 3.825 and some other stuff. Okay. Negative 6 plus radical 30 equals, divided by 3 equals, and this one is negative 0.1742 and some other stuff. Okay, so now you're going to ask me, oh, great. So these are the intercepts. And I'm going to say, yes. And sure. And why not? And you're going to say, well, how in the heck am I going to graph this? And the answer is you're not. You're going to guesstimate it, and you're going to use a calculator, a graphing calculator, or a computer if you need a beautiful graph, because humans cannot graph this. I don't care how careful you are. You could probably get out to 1 decimal place, maybe even 2, depending on what your drafting skills are like. But realistically, you're not going to be able to do it. So let's look at what we've got. Let's do a summary on this page since I've got some space. Let's summarize this problem. I've got a parabola that opens downward. I've got the vertex is at negative 210. I've got one intercept that is nice, and that's 0, negative 2. And then I've got some nasty ones. I've got negative 6 minus radical 30 all over 3, comma 0. And I've got negative 6 plus radical 30 all over 3, comma 0. Now, that's not enough to graph. That's really not enough to graph. That's going to be very difficult to graph this graph because there's only 2 points that we can realistically graph. Technically, we've got 4, so that's what the problem requires. But what I would encourage you to do, and it's going to seem so simple compared to all the work we've been doing, but I encourage you to go ahead and plug in some values. So we need more points. So I see that I have a vertex when x equals -2, and I have an intercept when x equals 0. So between these two, I'm going to try x equals -1. It's between, so there's a good chance that the y value will be between these two. So y equals -3 times -1 squared minus 12 times -1 minus 2. Okay, so this is -3 plus 12 minus 2 is 7. So I've got the point -1, 7. So that's another point. Could I go for some more points? Absolutely. But I am actually thinking that with these 3 points and with these 2 guesstimated points, I'm going to be able to graph this thing and give you something pretty. So let's go ahead and give it a try. Okay. So here's our graph. I'm going to overlap this. Let's see if I can scooch this all into the same graph. Can you kind of see this? Not really. Can I open you up a little bit? Sure. Okay, you're going to have to take my word for a lot of this, because I'm not going to be able to squish this down far enough. Okay, so our vertex is at -2, 10. So I have to be able to get up to 10. So if this is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So I'm going to put my x-axis right here. Obviously, I'm always going to be using a ruler. Always use a ruler. The x values are relatively close to 0, so I'm not going to worry about trying to put the y-axis anywhere particular. I just need a little bit of space on both sides. I've got a point -1, 7. So 2, 3, 4, 5. There's 5, 6, 7, 8, 9. There's 10. So 7 is right here. That's -1, 7. That's that point, the extra point that we graphed. There's a vertex at -2, 10. Okay. I've got an intercept at 0, -2. That's my intercept. And now I'm going to use, this is my vertex. This is my axis of symmetry. X equals -2. That's my axis of symmetry. All right, I'm going to write it on this page on the summary. If the vertex is, oops, let me show you. So you'll have this in your notes. If the vertex is at -2, 0, 10, -2, 10, then you take the x coordinate and you make that into a line. And that's the axis of symmetry. And let me show you a little magic. This is desperation. These are helpful hints from desperate students, because I have also been a desperate math student and looked at this and gone, how the heck do I graph this? And the answer is there's an axis of symmetry that goes through the vertex. Everything is on the same on the left and the right. So if I move 1 to the right and I go down 3, then if I move 1 to the left and down 3, there is a mirror point. This point mirrors that point. Okay, now this one, from the vertex, I move over 2 to the right and I go down to -2. So if I go 2 to the left, I go down to -2. And voila, these are mirrored from each of those, right? So this point is a mirror. This point is a mirror of this one. And this point is a mirror of this one. And that is how I get myself 5 points that I can graph on. Remember, don't make the top of a parabola pointy. The top of a parabola should be round. It's not always obvious how to do it, though. So, you know, we're human. Cut yourself some slack. There we go. And then I'm going to say that here's, and you can see that I have, let's look at what our intercepts were supposed to be. Negative 3.8 and a bit. And then something that's really close to 0. So let's look over here. There's the one, there's the other. How do I label these? Well, I put in the official ones. This is negative 6 plus radical 30 all over 3 comma 0. This is negative 6 minus radical 30 all over 3 comma 0. And I make it make it seem like, oh yeah, I totally just graphed those. Yeah. Oh yeah, no, in my spare time. And that is how you do a very hard, very, very challenging parabola problem. Woohoo. Hopefully there was a little bit of beauty in this. Hopefully the bears are happy. Rah. I mean, let's be honest, even Godzilla is happy. Yay. Okay. Next up, we do a not as hard parabola that's a little more weird. And woohoo, math on.